implementing dtrace into your own JavaScript application code, I guess we can sort of extend this more generally to talk about the whole paradigm of just like the generate DOF, and I acted that down into the kernel, and I'll just cut a whole bunch of stuff out of this. Well, we'll skip that. Who in the room is not familiar with node.js before I start and like go through this? Okay, there's enough hands to go up. I guess I will talk about this. So Node is ultimately, it is a server-side JavaScript technology. You know, so you can sort of like mentally replace in your mind, replacing the Ruby interpreter or the Python interpreter or even the JVM with Node. Like that's effectively what it is. All it is a dynamic toolkit that you can write, you know, programs in JavaScript in that are not running in the browser. You know, in particular, it's given you this environment to do that, and what it has done a very good job of is giving you networking, HTTP, file system I/O. You know, effectively a lot of the things that exist in like man section 3 in the API. So that's just sort of, you know, what you can think about it doing. You know, the next logical question is like, well, what the fuck would I want to run JavaScript for, like on my Unix server? And you know, what it actually turns out that it's really good at, as we found, is you know, you want to prototype some network app specifically, and you want it to talk to other things, and highly likely that you want it to drop in some existing, to replace some existing protocol, because that thing is, you know, 30 years old and doesn't do exactly what you want. Two cases in points that we have from Joint that have worked, that have sort of been a proving ground for us, just to mention, are one, I think I did a word count on it. I think it's like 400 lines is a, you know, complete implementation of the DHCP protocol running in Node. You know, we're a cloud computing company. You can just imagine when we provision you a virtual machine, we need to assign that thing an IP address. We want to tightly control what happens there, how we track it, you know, yada yada yada, or you know, ... profit. So effectively, we needed our own. And you go think about like, well, I'm going to go like replace the one that exists in, you know, Unix, and like it's this 30-year-old C program, and like it's, you know, sort of kludgy. And it turns out actually you can write it really, really quickly. The second one is one that I did, which is writing our own LDAP server. So we have written a complete implementation of LDAP in JavaScript with the sole purpose, of basically getting ourselves out of the boat of running something like Open LDAP replication. And you know, that's a complete different tangent that I will like, you know, for me personally, it's really hard not to go down the road, but I will resist that temptation.
You say network apps, you specifically mean TCP apps, don't you?
Oh no, it does UDP as well.
TCP also?
Yeah. Right, so I mean basically, and it gives you the socket API, right? It gives you a JavaScript interpretation of the socket API. Like, quite literally, imagine man section 3 existing in JavaScript.
PCAP.
What's that?
PCAP.
Yeah. And you know, I guess like the last point, like when you think about comparing this to like Python or Ruby, is like, well, Node is actually really fast, mostly because it's brought V8 over, and is, you know, it has two things going for it. One, it's brought V8 over, and two, it's just a very good implementation of the event-driven paradigm, right? So you get an event loop, you get one thread. Clearly, it's got threads going on in the system. There's a whole bunch of like internet nonsense where people think it's not threaded. It does, they're just not exposed to you. And it's just a good implementation of it. So, you know, in particular, if you think about writing these things in any other language, of course you can. But when you're at the result of like writing, say, LDAP in Ruby, you'd probably get like, you know, 10 TPS out of it. So like, yay. You know, at least with Node, you get something that you can actually run in production, and you know, it's some reasonable number. So let's move on to what this talk is actually about. And you know, I prepared these slides. So one, I'm talking really fast. And two, I'm going to judiciously just drop slides out of this talk. So you know, bear with me if I start skipping things. It's probably prudent to talk at least about what Node exists, or what dtrace exists in the Node interpreter itself, before we talk about implementing or instrumenting your own application code with dtrace. So I'll briefly touch on that. They're completely plagiarized from Brian Control slides at some point. And then I'll go through some examples of, well, one, I'll explain how the dtrace provider works to answer the questions about like, you know, the generated DOF paradigm for Node. And I'll just, you know, kind of quickly go through some examples of the things I've done with it, of putting it into these frameworks for, you know, the LDAP implementation in JavaScript, and Restify, the thing Dave and Brian alluded to earlier. So, is there a question? Or?
One question. I noticed I think on the Joint website, LinkedIn is using like a client piece of this on a mobile app talking to your systems. Is that true or no?
Brian, is that true?
I mean, LinkedIn is a customer that do a lot of things. There are a lot of people using Node for a lot of reasons. I mean, to give you one high-profile example, the Boxer example is a social talk app that uses Node. Lots and lots of things.
It may or may not have been on Brett's slides.
Exactly. Okay. So there are lots of usages of Node. I mean, I don't know what the rest of the question is, but
yeah. All right. So what do we got here? Okay, so the probes that exist in the dtrace core itself are similar to like what exists in any other interpreter. You've got USDT probes written into Node, and I'm really not trying to like dismiss this as hand wavy, because clearly, as has been alluded to, like Dave Pachenko has suffered an enormous amount of pain getting this in. You've got effectively probes that give you a good overview of what your system is doing around socket operations, HTTP, and GC, and you get this coarse granular overview of what your stack is doing, and it does get you a long way, right? Like here's some sample one-liners. Wow, this is like, by the way, thanks, Brian. The first one there is just going to like on every second interval just tick by and print out to you like effectively the HTTP request line plus the client IP address. The second one is just going to aggregate. The second one is just going to aggregate your top end, or actually all of your IP addresses sorted in ascending order when you're done. And the third one will just tick by and show you garbage collection times as the node process is going. And so, without you doing anything, when you write a web app, you can actually get a lot of information about what it's doing from the outset. However, you're not really able to get a lot of information about what each step of your app is doing. David kind of mentioned this earlier, that like a lot of these things, if you're familiar at all with like the Java intercepting filtering pattern, is like the J2E wankers came up with. Effectively you like break down an HTTP request into a whole bunch of like little tasks. And it actually turns out it's a really good pattern for managing code. Ironically, like the thing Theo just showed on the last talk, the APR hook thing is like, it's the same thing, right? Like ultimately you map a request to like a pipeline of things. The example here is really like, well, given that's like the pattern, wouldn't it be nice, well, let's just skip that. Suppose you had something that like, here's an example, right, of like one in the Restify framework where you have effectively two things composing the life cycle of a request. And what would be really nice is actually if you could see, being the world's worst programmer, clearly I've done the time-honored tradition of inserting a sleep into my code. What would be really nice is that actually I could see that broken out in production. And it turns out actually, well, here's a little D script that, your time-honored, like, start done tracking thing. And I can, in fact, see that, right? This is just, rather than taunt the demo guys, I figured I'd like pre-script this. Effectively all I've done here is run that initial server example, which had two functions called on every request, and just ran some sample requests against it and Control-C that D script. And we can see clearly that whatever that thing is named slowdown on that, on that pipeline is taking the lion's share of the request time. It's an interesting question I had when I ran this of like, why exactly are there any cases where an echo server the echo function is taking 2 milliseconds, but we'll leave that artifact for another day. Anyway, so the point is, we went from this where we didn't really have any dtrace in our application code at all, and we're able to clearly identify in there what was going wrong. By the way, as I'm trying to like speed talk through this to fit this in 15 minutes, it's like, okay, am I going too fast, or is it good? Sweet. All right. So what actually just happened there was some magic in Restify where Restify goes and creates these dtrace probes for you literally the code of it looks very, very similar to what Theo presented in Apache, just in JavaScript, where we have this like loop where we iterate over all the handlers and we automatically insert a probe for start and done of the overall route, and then a probe for start and done on every single handler that will run, and just fire them as we run them. This is sort of where the thing that was alluded to earlier. The lion's share of the work here really goes to Chris Andrews. Frankly, he should be up here giving this talk, not me. He has written a module called the Node dtrace provider, which lets you do this. I'll show you an example of like what that looks like programmatically in just a moment. It installs on every platform. It obviously is only useful on platforms that have dtrace, but why would you be anywhere else? I don't actually know if it works on FreeBSD. I'm sure if it doesn't, he would fix it. And notably, you don't need to be root to run this, which is pretty nice. What this is Brian had mentioned this before. This is actually the third time he's done it. He has written the same technique for Ruby and Perl, and he's actually factored all these things out now into this library called libusdt, which he's sort of finishing up as we speak. And the intent being that he can add new features to it in the future and add more language support for it. So Python, I think, was next on his list. Erlang would clearly be a candidate. We can add more. It's super spiffy. What it does is this is sort of the magic goober is if you have this API where you say I want to go and create a provider and then I want to go register any number of probes and I like get that all set up, and when I'm done I call enable, or his version method name called enable. And what he does is he's literally gone reverse engineered the user lib dtrace.h. According to him, he literally only had to follow the comments of lib user dtrace or user lib dtrace.h. So, apparently kudos to you comment writers. And he just generates the entire DOF in memory in binary, and just when you call enable, that is just literally a pass through to ioctl and just blast that down into the kernel. He's got a blog post with a bunch more information about what he sort of went through to get to this technique. He actually said he was at the 2008 dtrace conference, and he got this idea from the Java guys who were talking about doing exactly this to implement Java code. And he said, well, funnily, I'm not even sure if to this day they've ever shipped this for Java. They certainly didn't ship it for 2 or 3 years afterwards, and he'd already done this for these languages in the meantime. So at least it went to good use for this purpose. So here's an example of how you use it, which this is sort of the meat and potatoes. I've written the world's worst version of cat here, which clearly does no error checking, in Node. And effectively, all this does is you run this thing on the command line and give it a list of file names, and it will just call the Node read file API and pipe that to standard out. Except this one has dtrace timing, dtrace probes rather, inserted before and after the read of each file, so we can get timing of what, specifically what is happening in our JavaScript code and not what the system thinks. And if we look at line 3 there is where we go ahead and create a provider, and you have to give it a name. So this is just the nodecat one. Lines 4 and 5 are giving you the start done probes. Argument 0 I just used as the file name, which you'll see in just a second is wise choice, I think. And then just for kicks, I basically made argument 2 be a nullable error code if the read through an error, and argument 3 is the number of bytes that were read and piped out. And you can see at lines 8 and 12 that firing before and after every file read. So, the reason it was a good choice to make argument 0 be the file name is because you can then piggyback on the syscall provider and diff the time that you're spending in Node, or effectively diff the time that Node thinks it's taking to read a file versus the time the system is taking to read a file. And this entire janky D file, which is a little bit ugly, not for reasons of D, but for reasons of Node, is what does that. And when you run it, here's just a sample run it where I just converted to microseconds to make it easy to read. It turns out actually Node is pretty good, right? We have, given the fact we're in JavaScript, you've got roughly 100 to 300 microseconds of overhead, which is pretty good considering it's JavaScript. However, it does this really janky thing, which it's amazing what you find when you look, right? So I'm working up this example, and I'm trying to write that D script and can't get it to work. I'm like, what's going on? It turns out actually, if you don't recall from man section 2, read says if read returns 0, you're at end of file, stop calling read. Well, Node apparently just throws that out the door for whatever reason and calls it over and over and over and over and over. And it's literally 100 times later. So that entire D script is basically to extract out the first time read returns 0, since clearly the system is ready to move on, and track that until we finally end up in the last case. So anyway, that's a random tangent. I just had to share. That's my own little mini war story, making up an example for this conference. Anyway, so let's move on and go through briefly some examples of how this was put to use. Here, if you're not familiar with LDAP, it's probably completely out of scope, especially with 15 minutes of window to talk about LDAP. It's a directory service protocol, and you can do things like add, search, delete to it, and blah blah blah. This is the hello world example in LDAP.js, where we have effectively just echoed back a search for some part of the tree. And when we have that, we then doing a dtrace LP shows us that we actually have a bunch of probes available to us, which are not showing up on this resolution, for server search start, server search done, and server search entry. There are a bunch more for all the other operations, but since the only thing I wrote up here was search, that's all I showed. Start done, obviously fire when you think they fire at the start and entry, start and completion of a search request, and entry fires for every record that gets returned to the client. So it's just spit out every single time. Sorry, what's that?
Neil's got a question.
Yeah, sure.
Yeah, LDAP esoteric question.
Oh, you're going there, aren't you?
Yeah, what underlying ASM1 implementation did you use?
I wrote my own.
Wow, nerd on nerd dominance.
What's that? Yeah, take that.
Mark snaps at the
so
I hope you fuzz tested it. ASN1 is nasty.
Yeah, I'm aware. So the problem was I went to look through I can't resist, right? It's like you're trolling me to like rage on LDAP. You know, like I wanted to like just rip that stuff out of the C library of something that's clearly had around for 30 years, and it turns out none of it is like really extractable in any sane form. What I ended up doing was, you know, more or less like porting the open Java implementation of ASN.1 over. So, you know, I mean, it was still horrendous, and you know, it's janky for a bunch of reasons anyway. Why'd you ask that question?
I was looking for an answer.
I paid him $20.
What's that? You paid him $20? Yeah, that's your fault. You know, in the spirit of Brian, there's some one-liners. The first one would do exactly the same thing, but an LDAP speak just sits there and ticks by and tells us, you know, every time a search request is fired, where it looks like in the tree, you know, what the filter, if you're not familiar with LDAP. You can think of it sort of like a mini form of SQL. It's just like a way to, like, you know, you get and, not, or analytics tool that we have in Joyent. Here's you know, Robert was kind enough to go and write metadata for that, which basically this was just me running like 10,000 ads through our internal LDAP server just to visualize the latency of that. You know, we can basically plot this now with, you know, lovely heat maps and, you know, see all that kind of stuff. So that actually said, it's you know, it's been incredibly handy for us to have that dtrace available to us in the stack. And the lesson I sort of learned from LDAP here was, well, when I started, this is the first time I'd done this, and when I started this project, you know, I sort of just like mirrored what had been done in the node HTTP provider for, you know, it seemed like a good starting point. And at the end of it was sort of when I realized like the revelation of like, well, what I really want is actually not this like overall view. I want this all broken out into piecemeal steps. And so Restify is, you know, a similar sort of framework where you write HTTP REST services and you set up pipelines of requests. And so, you know, it takes the same paradigm except does what the initial example did and give you start-done probes around every handler, right? So if we take like, you know, getting slightly closer to a real-world example, here's something that like for every given request is going to like, when we read this and go through this, is going to go through, do content negotiation, authentication, look for expiration of the request. It's going to do query parsing, body parsing, still do a sleep, and then finally echo back, you know, your name. And when you go and do, you know, dtrace LP on this now, you actually see, you know, quite a bit more, right? So we still see, now we see this, you know, these names are predictably picked. So we have, you know, effectively the get method, the URL of hello name, and then all those given function names. And so the names for the actual probes are, you know, predictably picked on that. That's a tongue twister. Where, you know, you can see basically we have route names dash, you know, your function name dash start dash done. And so taking the same descript as before, now actually when we run this, we actually see all the data for my entire pipeline of requests. Indeed, my sleep is still, you know, the lion's share of the time. But you can start to see where this is going, right? If you take any like modern web app, they're probably going to talk to some like backend system to do like IP whitelisting. They're going to talk for something to do authentication. They're going to do authorization. They're clearly going to do something to look up a resource. You know, maybe they're going to do metering, maybe they're going to do auditing, maybe they do billing, like, you know, blah, blah, blah. You have a long list of things where you're talking to other backend stacks off box. And, you know, this is where this sort of shines and it's really valuable. You probably just skip this. This is, you know, this is just the code, you know, that wraps up adding probes, but, you know, that's probably pretty obvious from what was shown before. Just a few tips on, you know, using this. I was trying to find the most awesome other unicorn picture I could find, and Mr. T riding a unicorn came in pretty close to the top. You know, whenever you can, all the pictures are backloaded here. Whenever you can, you know, like as the Node.js example showed, you want to piggyback on everything else in dtrace. You can correlate as much as you can. All the Restify ones, for example, the argument 0 is always the same argument 0 that all the node built-in HTTP probes have. So you can correlate from anything that the node HTTP provider has that Restify doesn't, you know, into your things. So that's, you know, if there's nothing else to like take away that. And this is an artifact of something I think we want to open up and like talk a little bit more about this. The dtrace provider for artifacts of, you know, ease of implementation only supports 6 magic args. So you get to pick 6, and they have to be char stars or ints. So you have to pick really wisely what you want to display, right? It forces you to like weed down what the bare essentials of your probe is. It would be really nice actually if we could, you know, do more than that. And then, you know, this is as was just shown, right? You want to put this as low as you can into the stack so you can get the most value out of it, which actually, I love Theo's presentation because they did the exact same thing for Apache, right? Wherever, well, an artifact of Node, if you haven't written stuff in Node, is, you know, since it's completely asynchronous, you end up in this like control flow problem of trying to like, it's very difficult to do iteration, actually, it turns out. And so most people end up using either a homegrown recursive thing like I do in Restify, or this very popular library called async that does it for you. And while that's a pain in the ass, it's actually a very good place to put probes because that's probably the place you're sequencing events. So do that. This should be obvious at start and done. And then the last thing to close out was just sort of what was obviously talked about this morning is what we really want is dynamic translators so that you could model a probe as like a job. Like ideally what would be nice is if instead of having this flat list of 6 arguments, you could say, well, actually, I have a JavaScript object or a Ruby object, whatever, and that really maps to a struct. And I can describe that whole thing and make my probes as arbitrarily complex as I want in the dynamic language as I'm able to do in C. That would be by far the most valuable thing we can do. There's an artifact of his module is I mean I think there's actually an artifact of dtrace, correct me if I'm wrong, where you can't once you've set up the probes for a provider, you can't go ioctomorium. Is that true?
That's right.
Right. So that's a little bit of a pain. I guess actually that's probably an artifact of dtrace thing and not an artifact of his module.
How much of a pain is that? I mean that.
So like as an example where it's a pain is like you have some server process that gets set up and like in particular if you're doing something where you're dynamically loading some plugin after the fact, like you're deal opening something, you don't actually know what's coming, and if you're doing that after you've already like set up and started listening for requests, then it's you basically just have to like block that, right? You can't do that.
That's a solvable problem. I mean, it's ugly, but it's solvable.
Yeah, I mean, it would be nice. I don't think it's huge.
Are you more likely to tack them on than take them away? Take them away gets
no, I personally don't think I've ever seen a reason where I would take them away. Okay. The reasons I've had in C, I've certainly seen the case where I would like to be able to deal open and like add them on. In JavaScript, and it's mostly like, well, I lazy loaded some client library that I want to have dtrace probes in. It's not really a deal breaker, just it's sort of convenience. And this is an artifact. The disabled probe artifact is an artifact of Chris's library, which in the new he's having a breaking API change in libUSDT, which will change that. Effectively, his API will look much more like you create a provider, you create probes out of that, and you have to hold on to that probe, and you can only fire on the probe instead of firing on the provider. So basically, he has to do no lookups ever to do that. That said, I was actually discussing this with Brian at one point in the conversation. I think the statement you had was like, man, your code would be really fucking white hot for like that disabled probe effect to be what bites you. So it's not a deal breaker. Like the one that is by far the biggest is the dynamic translator one, right? That's the one that really it really hurts actually. So that's. I think I managed to come down. I don't know how long that was, but the turbo version of this. So dtrace all the things. So.
So implicit in these USDT probes that they're tied to a particular address, and I don't know how much that matters for the VMs you're talking about. But it seems like if you're in a JD VM, which is going to move those addresses around, that's a real problem.
He doesn't know. He's not. He's a native code.
Yeah, he's everything he's done is a native code.
So when you call that fire method from JavaScript, so you're jumping into native code and then from there to a specifically allocated static key.
Understood. So my question is not that I'm not going to observe something that doesn't work here, obviously it does. My question is, would it be useful to have a mechanism for invoking the probe from userland, which was now not bound to a particular virtual address? So for example, that would let the VM invoke a probe and have like as an argument some cookie that the kernel gave you that was associated with it. So you could move that execution point wherever you wanted and not have to enter into native code if the probe,
if the VM
probe is disabled, for example.
Well, if in that case, I think what you're describing, the VM would have to have that support in it itself,
Yes.
right?
Yeah.
Yeah, I mean, I think, like, frankly, the reality of, like, the likelihood of V8, for example, putting native dtrace in is probably not that high, right? So I think, like, it's clearly what you're describing would be cool, but, it seems like it doesn't seem like it's that big of a win.
Are other frameworks incorporating Chris's work and doing dynamic USDT providers? And other, in particular, it would be great to have this for Rails. We're just talking to the Molotov guys.
Yeah,
exactly. But yes, the Molotov guys strongly agree with this, probably thinking the same thing, right? I mean, it's like, how much would you love to have that for Rails? And I think that
I don't think it's just us either.
I don't think it's just.
I think we're one of the few Rails shops that's actually curious about this because we work so closely with Joint. Like, I think tons of Rails shops would love to have better visibility than just New Relic, which is kind of just like this tantalizing like drop of ice cream and walk on the phone.
And I mean, it seems like Chris's work is a much easier vector into that than forcing. I mean, you can. It'd be interesting, like maybe to figure out what some of the key points are in Rails. Because it seems like, I mean, he's done the Ruby dtrace provider. It seems like it should just be a matter of kind of blocking and tackling. I mean, it shouldn't be that difficult for someone in the Rails community to take his work and do what you've done.
No, it's trivial, right? I mean, that's I think like the macro point here is, I mean, it is completely trivial for you to go add dtrace into your application code and have that be semantically meaningful to you. You know, Rails would be like the quintessential Ruby framework where that matters. I think he did tell me that I think he's seen more uptake in Perl versus Ruby. That I'm like way out of touch with what the hot frameworks are in Perl, if such a thing exists. But I get the sense that like there are some that have picked it up in the Perl community. I don't actually think many people have picked up in Ruby or Node yet.
Well, I think it's just the problem that like, there's kind of the folks that are. I mean, you guys are
A lot of
so
many Rails shops are Linux only and are just allergic to anything that has to make with dtrace. So,
which is a good segue to talk on the
Right.
Linux dtrace folks are here. So
what kind of uptake do you see in the Node community? Because Node Summit this year was very interesting in terms of the vast number of the attendees at Node Summit were kind of really interested in the dtrace and the kind of analytics that they get from SmartOS and also from Joint. But the thing that struck me when I was talking to most of the developers was the fact that they just didn't know how to actually instrument their code.
Right.
I just don't think this information is widely enough known in the Node community.
Yeah, no, it's definitely not. Like, I mean, as far as I know, I have the only two frameworks that are like have any sort of uptake with it. I know other people have seen that and have started playing with it in Node, but I don't think anybody else has really gone and run with it.
Because Chris stuff work on the Mac, I mean, it should.
Yeah, I actually do. I mean, I bounce back and forth with some Mac all the time.
I did development work on Mac using it.
So I think that's going to be the vector to a much broader audience.
Yes.
To use the, I think someone had the tweet earlier observing that everyone had a dtrace enabled device in here, but that's largely because they're all on the Mac laptops.
Right.
That's going to be our vector into kind of the broader Rails communities.
Yeah, actually, all the examples I cooked up were run on my MacBook. So yeah.
Yeah, the other interesting vector you might want to consider is developments that are happening with Apple as far as iOS is concerned as well.
Yeah.
My question was, how many bugs did you fix because of dtrace giving you answers to, like, showing you issues?
Yeah, well, I think the answer is a lot, frankly. I mean, I think the answer is a lot and growing, right? It's not like we literally use this all the time. Actually, Keith and I have been.
Code's not bug free yet?
What's that?
You mean the code's not bug free yet?
Amazing, isn't it? I mean, especially writing your own ASN1 library, right?
I asked this because the C library was like, statically analyzed and ripped apart by people for the last 30 years. Your code has been running for maybe a couple of weeks or months, and it's running on dtrace, which gives you an output of its characteristics. And so, are you able to get that rate of bug fixing that the C library has had in the last 30 years with dtraces?
I don't know how to answer that question because clearly I have, there's not been 30 years of running with my code. I think the way to answer the question is that when we've had bugs that have come up, and both for performance bugs and for just general, I want to understand what's happening bugs. I mean, dtrace just dramatically reduces the amount of time it takes you to troubleshoot that. So I mean, like once upon a time in a former life, I worked for Amazon, right? And I caused this massive outage. And I remember like literally burning weeks. I'm not exaggerating, weeks trying to like go postmortem through graphs and like figure out what the system went wrong. And I reflect back now and like, well, it would take me 2 hours now to like cook up dtrace. I did that. It could only take Brendan 2 minutes. And but it just dramatically reduces how long it takes you to go from I have no idea what's going on to I understand. I can see what's happening in the stack.
I think maybe a different vector for the same answer is observability.
Yeah.
As far as Node is concerned, you'll find one of the big problems that most people have transitioned into Node is asynchronicity of their code and not understanding how that actually causes their programs to operate.
Yeah.
And with using the dtrace providers, it gives them fantastic insight into exactly what the hell is happening in their own code base. things that they didn't initially envisage. They can actually see a visual kind of feedback of, is that what's happening? Those probes shouldn't be firing in that order. There's no way that interaction should be occurring. Hey, it's happening. This gives them an asynchronous viewpoint into the system that they didn't have previously. So it's a slightly different approach to same kind of.
Yeah, I mean, it's because JavaScript, like, you can't analyze it.
Yeah.
I'm sitting here thinking that in the case of like a node where a typical node app may be very asynchronous, the heat map kinds of approaches might be interesting because one of the things that heat map, we saw with Brendan's things, heat maps helped us identify patterns. And when you get a lot of asynchronicity going on, the human brain being able to understand those patterns and anticipate them is difficult. But being able to take something like the heat map approach and apply them and be able to see, oh, that's what's happening. I can see that being potentially enormously powerful.
Yeah. Cool. Anything else? Guess not.
Mark, thank you.
All right. I got Scott.